Good day everyone! You are watching Mathfinity, where math learning is fun and exciting. For this video lesson, we will be guided by the most essential learning competency number 3, and that is determining arithmetic means and n term of an arithmetic sequence. As stated in the most essential learning competency, for this video, we will be dealing with the n term of an arithmetic sequence. And to establish our lesson objectives, here are our objectives. First, derive formula for n term of arithmetic sequence. Secondly, solve for the n term of an arithmetic sequence. And lastly, solve word problems involving n term of an arithmetic sequence. Let's continue by recalling what does arithmetic sequence mean. An arithmetic sequence is a sequence where every term after the first is obtained by adding a constant d. And we know that constant d represents common difference that can be solved by solving the difference of any two consecutive terms. In symbol, that is d is equal to a sub n minus a sub n minus 1. Let's consider this table for example. This table represents the appearances of Halley's Comet as discussed on the previous video. Suppose we want to determine the successive years of appearances of this comet. For example, the sixth appearance. We will consider its period for it to orbit the Sun, and that is 76 years, which we considered as the common difference. To determine the next year of appearances, we will add 76 years after each term, arriving at this table. Studying this table, the first appearance was 1758 and the fourth appearance was until 1986. If we want to determine the sixth year of appearance of this Halley's Comet, starting from the fourth appearance, we'll just continually add 76 in each term. So that is 1986 plus 76, that is 2062. And that is the fifth year of appearance. But you are asked to solve for the sixth year of appearance. So we will just add again 76 to the previous term, which is 2062. And that will become 2138. Therefore, the sixth year of appearance of this comet is in the year 2138. The process that we use to solve this example is what we called recursive sequence. A recursive sequence is a sequence in which terms are defined using one or more previous terms, which are given. This just simply means that you always need the previous term in able to identify the value of the next term. Another example is, suppose you are asked to solve for the 12th year of appearance of the same comet. By following the recursive sequence, again, we will just continually add 76 years. So that is 1986 plus 76, 2062, plus 76, 2138, and you continue adding 76 until you reach the value of the 12th term, and that is 2,594. Therefore, the 12th year of appearance of the comet is at the year 2,594. What if you are asked for the 100th appearance? Will you just add 76 continually? I guess not. So, it is important to analyze the pattern and develop a rule or a formula which generates the terms of the sequence. Let's now derive the formula for the n term of an arithmetic sequence. To do that, we must remember what is the definition of arithmetic sequence. And of course, analyzing the terms given in an arithmetic sequence. As we recall, arithmetic sequence is a sequence whose terms after the first is obtained by adding a constant d, and that's common difference. In our example, the first term is 1758. So to get the next term, we will add 76 to 1758, and that is 1834. But for the sake of our analysis, I will leave that as 1758 plus 76. In representation, second term could be written as a sub 2 is equal to a sub 1 plus the common difference. So we continue to the third term, and third term can be written as 1758 plus 76 plus 76. Our reference point or reference year is at the year 1758. On the other hand, third term or the third year of appearance can be written as the third term is equal to a sub 1 plus twice the difference. Then the year of the fourth appearance is equal to 1758 plus 76 plus 76 plus 76. And it is equal to the equation, the fourth term is equal to the first term plus thrice the difference. And we continue until fifth term, that is equal to 1758 plus 76 plus 76 plus 76 plus 76. And that represents the equation fifth term is equal to the first term plus 4 times the value of the common difference. Looking at these equations, can you observe a pattern? Remember, these subscripts at the left side of each equation represents the value of n evaluated at different terms. What patterns exist in n and the coefficient of d? Let me guide you through this observation. What is the value of n in this equation? The value of n used to evaluate that is 1. How about the coefficient of the common difference? This equation is the same as a sub 1 is equal to a sub 1 plus 0 times d. In this equation, what is the coefficient of the common difference? That's right. The coefficient of the common difference is 0. Now, let's proceed to the second equation. What is the value of n in this equation? A sub 2 is equal to a sub 1 plus d. The value of n used is 2. What is the coefficient of the common difference? That's right, that is 1. So, n is 2. The coefficient of the common difference is 1. Let's proceed to the third term. What's the value of n in this equation? The value of n in this equation is 3. And how about the coefficient of the common difference in this equation, a sub 3? That is 2. N is 3. The coefficient of the common difference in this particular equation is 2. Let's proceed to fourth term. In this equation, the value of n is 4. How about the coefficient of the common difference? That's 3. Good. How about in this equation? Fifth term is equal to a sub 1 plus 4d. N is equal to 5. What's the coefficient of the common difference? That's 4. Can you observe a relation between n and the coefficient of the common difference? In this set of equation, the value of the coefficient of the common difference is always 1 less than n. That means any term of an arithmetic sequence or n term can be generated by the equation a sub n is equal to a sub 1 plus the quantity of n minus 1 multiplied by the difference, where a sub n is the n term, a sub 1 is the first term, n is the number of terms until a sub n, and d is the value of the common difference. Using this formula that we have just derived, we will try to verify that the 12th year of appearance of Halley's Comet is indeed 2594. But before that, let's identify the given. We know that the first appearance we let is 1758, and the common difference is equal to 76. And since we are evaluating the 12th term, we let the value of n as 12. And the 12th year of appearance is being asked. By substitution, the 12th term is equal to 1758 plus the quantity of the difference of 12 and 1 multiplied by 76. By continuous evaluation, that will become 1758 plus 11 multiplied by 76. And the product of 11 and 76 is 836. And that is added to the first term, which is 1758, and the 12th term is 2594, which is the same as our answer through the process of recursive sequence. In this exercise, try to predict what will be the year of nth appearance in each number. You will answer that within 2 minutes. And 2 minutes start now. Time's up. Let's now check your answers. In number 1, given the sequence 1758, 1834, 1910, 1986, and so on, we must find the 22nd term. So let's identify now the given. Of course, the first term is 1758. Based on this, the common difference is equal to 76. And the 22nd term is being asked. So by substitution, the 22nd term is equal to 1758 plus the quantity of 22 minus 1 multiplied by 76. 22 minus 1 is equal to 21. And that is to be multiplied by 76. And the product of 21 and 76 is 1596. Added to the first term, which is 1758, the 22nd term is 3354. Next. Using the same sequence, in number 2, we must solve for the 31st term. So we have the given us 1758. The common difference is 76. The 31st term is being asked. Therefore, the value of n is 31. By substitution, the 31st term is equal to 1758 plus the quantity of 31 minus 1 multiplied by 76. 31 minus 1 is 30. That's multiplied by 76. That is 2,280. Added to the first term, which is 1758, the 31st term is 4,038. Did you get all the answers correctly? If so, you are doing great! To continue this video lesson, let's have independent practice. Find the n term for each arithmetic sequence. You can pause the video for you to answer at your own pace. Number 1, the first term is equal to 17. The common difference is equal to 1/2. N is equal to 16. Number 2, the given sequence is 2, 9/5, 8/5, 7/5, 6/5, and so on. And the value of n is equal to 26. Number 3, the first term is equal to x plus 1. The common difference is 3x, and n is equal to 40. Let's now answer. Number 1, the first term is 17. The common difference is 1/2, and n is equal to 16. By substitution into the n term, that will become 16th term is equal to 17 plus the quantity of 16 minus 1 times 1/2. 16 minus 1 is equal to 15. That is multiplied by 1/2. The answer is 15 halves. Added by 17, that is 49 halves. Number 2, find the n term for each arithmetic sequence. Given the sequence 2, 9/5, 8/5, 7/5, 6/5 when n is equal to 28. Enable for you to answer this, you must solve first for the common difference since the given is in sequence form. So we are going to identify any two consecutive terms and find their difference. In this example, I picked the consecutive terms 2 and 9/5. The previous term of 9/5 is 2. Then that is 9/5 minus 2. By finding their LCD, that will become 9/5 minus 10/5. And the answer is negative 1/5. Let's try to verify that the common difference is negative 1/5 by solving the difference at the different pair of consecutive terms. I picked 8/5 and 9/5 as consecutive pairs. So that will be 8/5 minus 9/5. Since they are similar fractions, just subtract their numerator and copy the denominator. 8 minus 9 is negative 1, and write the common denominator, which is 5. The common difference is negative 1/5. Since we have already the value of the common difference, we can now solve for the n term. By substitution into the formula, 26th term is equal to 2 plus the difference of 26 and 1 multiplied by negative 1/5. 26 minus 1 is equal to 25. So, there is a common factor between 25 and the denominator, which is 5. Since this is multiplication, you can cancel out 25 and 5. 25 divided by 5 is equal to 5. 5 divided by 5 is equal to 1. Then, multiply 5 and negative 1, that is negative 5. So that will become 2 plus negative 5, that is negative 3. Number 3, the first term is equal to x plus 1, the common difference is equal to 3x, and n is equal to 40. By substitution, 40th term is equal to x plus 1 plus 40 minus 1 times 3x. 40 minus 1 is equal to 39 multiplied by 3x, that is 117x, added to the first term, which is x plus 1. So, you are going to combine like terms. The like term of x is 117x. So, you can combine them. Since they have like signs of positive, so you will add them. X plus 117x, that is 118x. And since 1 has no like terms because this is the only constant, you will leave that as 1. So the answer is 118x plus 1. Let's now try solving word problems involving n term of arithmetic sequence. A theater has 32 rows of seats. If there are 26 seats in the first row, 30 in the second, 34 in the third, and so on, how many seats are there in the 32nd row? Of course, before we can answer a word problem correctly, we must analyze the given and think of its representation. We can do that by answering these guide questions. Number 1, what does 32 seats of row represent? Number 2, what does the number of seats in each row represent? Number 3, does the number of seats in successive rows form an arithmetic sequence? Why? Number 4, is common difference explicitly reflected in the problem? And lastly, how many seats are there in the 32nd row? Do you already have answer in each question? If so, you are now ready to answer the main problem. The 32 seats of row represent n, or the number of terms. Therefore, the number of terms in the given sequence will be n is equal to 32. Well, question number 2, the number of seats in each row represent the value of each term. If you will analyze the number of seats in each row, you will notice that the sequence 26, 30, 34 form an arithmetic sequence. The difference in the number of seats in any two consecutive rows remain constant. Therefore, it is arithmetic sequence. The problem did not directly state the value of the common difference, but if you will analyze the terms that make arithmetic sequence, you will find that the difference in any two consecutive terms is 4. Therefore, the common difference is equal to 4. How many seats are there in the 32nd row? It's our main question. So since we have identified all of its representations, we can now substitute that into the formula of n term. N is equal to 32, the first term is equal to 26, the common difference is equal to 4. What is the 32nd term? By substitution, 32nd term is equal to 26 plus the quantity of 32 minus 1 multiplied by 4. The difference between 32 and 1 is 31, and that is to be multiplied by 4. That is 124. That is finally to be added by our first term, which is 26. That's 26 plus 124, that is equal to 150. Therefore, the 32nd row consists of 150 seats. Did you get the correct answer? So you're doing great. Let's continue dealing problems involving n term of arithmetic sequence. Joanne started a new job with an annual salary of $150,000 in 2017. If she receives a $12,000 raise each year, how much will her annual salary be in 2027? Let us analyze again the problem by answering the following guide questions. Guide question number 1. What does 150,000 represent? Number 2. What does the increase of 12,000 each year represent? And number 3. What would be the value of n? And lastly, how much will her annual salary be in 2027? That is the main problem. You can pause the video, enable for you to answer these at your own pace. Let's see whether you answer each guide question correctly. 150,000 represent the first term. That is her annual salary at the year 2017. The increase of 12,000 each year represent the common difference. The value of n should be equal to 11. Why? Because 150,000 is the first term that is representing at the year 2017. To show that the number of terms is 11, we have here the table showing the relation of year, the number of terms n, and the salary, which represents the terms of the sequence. Since 150,000 is the starting annual salary, it clearly implies 150,000 is the first term, and therefore included in the number of terms. Is it clear? By answering the first three questions, we can now answer the main problem. How much will her annual salary be in 2027? We identify the given as first term is equal to 150,000. Common difference is equal to 12,000. N, or the number of terms, is equal to 11. And the 11th term, which represents the salary at 2027. And that will be equal to 150,000 plus the quantity of 11 minus 1 multiplied by 12,000. 11 minus 1 is equal to 10, and 10 times 12,000 is equal to 120,000. Added to the first term, which is 150,000, the answer is 270,000. The 11th term is equal to 270,000. Therefore, Joanne's salary at the year 2027 is equal to 270,000 pesos. Is that clear? Did you answer this problem correctly? If so, great job! In this video, we have learned to derive formula for nth term of arithmetic sequence. We also solve for the nth term of an arithmetic sequence. And lastly, we successfully solve word problems involving nth term of arithmetic sequence. I hope you learned a lot from this video. This is Sir JC, reminding you, math is easy when you perceive it positively.